Welcome back to Air Quality Matters. We already have the tools and knowledge we need to make a difference to the quality of the air we breathe in our built environment. The conversations we have and how we share what we know is the key to our success. I'm Simon Jones, and coming up, a conversation with Barry Cope, Group Managing Director of ATMA and SITMA, all part of the Building Compliance Testers Association, and importantly, he's the author of a new ventilation commissioning and testing course in the UK. You can't manage what you don't measure. And if you listen to this podcast, you know I'm a huge advocate of testing ventilation properly and often outspoken on the standards and outcomes we face in the ventilation sector here. Barry is a fellow campaigner in this regard and someone with deep knowledge and specific understanding of what it takes to measure and manage elements in the built environment, for example, air tightness testing. I was fascinated to talk to someone who's very recently just sat down and developed a course from scratch, what his views are on the sector, and, as an accidental advocate here, what good might look like. As you can imagine, this was an easy conversation for me, something very close to my heart and very, very relevant to many of the conversations we have on this podcast and out there in the real world. If you care about outcomes in ventilation and air quality, this is a great episode with lots of real insight from someone who's very knowledgeable and passionate about us all doing better. Don't forget to check out the sponsors in the show notes and at airqualitymatters.net. This is a conversation with Barry Cope. On the old trope that you can't manage what you don't measure, as someone who's recently looked at the state of ventilation in the UK, and I'm guessing as a kind of a testing organisation, come to the conclusion that something needed to be done. I'm interested as a kind of a first starter of a question, the starter for 10, what your broad perspective was of the UK ventilation market. And I guess it's a leading question. Clearly it led you to want to set something up to do something about it.
Yeah, there's a lot to unpack in your opening statement there. We, as ATMA, as the Air Tightness Testing and Measurement Association, never had intended really to get involved with ventilation. Us starting that journey was because we fell into that market. And it's no secret that the stats are out. The homes, new build homes in this country are becoming more and more airtight. We track that data. I'm sure we'll talk a lot about data, but we track that data and we can see month by month, year by year, day by day, the average air tightness values in this country. And we've got to the point where the air tightness levels have dropped and dropped and dropped. So homes are more airtight, less natural air leakage. But we found that the ventilation industry was broadly staying the same. It was on a, let's do the same thing. And it was never the ventilation industry that was taking the phone calls from national media saying, airtight homes are killing people. Airtight homes are causing mold. Airtight homes are bad for people. And partly because there was no real airtightness industry. There's not many bodies that kind of say, hey, we are the domestic, mainly ventilation body that looks after all this stuff. And we can answer that question. Because it's so spread across all the different trades. Sometimes ventilation is the plumber, sometimes it's the electrician, sometimes it's the labourer. Often it's all three as a combined effort, and then none of the testing at the end. So we as ATMA got dragged into the ventilation industry not by choice, but because we had to almost defend ourselves. So we at one point, after taking another phone call from the national media and Airtight Homes taking another round of battering, I said, you know what, we're going to fix it. So overnight, I instructed our developers, I instructed our training guys in here, our technical managers, and I said, we're now going to run a ventilation airflow commissioning certification scheme. And we are going to train up all of the people that do air tightness testing to enable them to do the airflow rate commissioning. And I thought that would be quite straightforward. It turned out to be the start of a journey over the last year or so, that maybe a bit longer than that, but the start of a journey that's really just opened my eyes to what has been going on and the fractures that have existed in the ventilation industry. I'll be very clear at this early stage, there are some brilliant people in the ventilation industry. There are some brilliant manufacturers that are really pushing their stuff, that are innovative, that, absolutely hate the idea of their products being involved in any of these problems. And they're proactively doing some, training and offering services, sometimes for free, or building it into their prices so that they don't get the slack of these things. But what we saw as ATMA is just gaps, I guess, is the most polite way of saying it. I kind of touched there: plumbing, electricians, labourers, sometimes site managers, sometimes Bob down the road who fits the kitchen, or Bob core a hole out for the wall. Sometimes people will assume a circulating hood is ventilation. There's an argument to say it's not. It's a filter. And so, it's a bit of a monologue to open with, but we just stepped into this world where we realized there was no cohesiveness. And, but I bumped into a lot of people on the journey that enabled me to, supported us on the journey and said, what you're doing is a good thing, but be prepared. So,
and I think we can.
It's been an entry.
We can unpack we can unpack some of that, I think. But I suppose you looked into the marketplace, and as a built environment assessor, as ATMA, as people that are measuring air tightness in buildings, you were seeing a gap in performance from a ventilation perspective. And I guess it didn't take, like most people, much rooting around to realize that every time we do a study or look at the outcomes in ventilation, that the percentages of homes that are non-compliant with even minimum standards is woeful. So it doesn't, for people that aren't in this space, if you're in a space of measuring building performance like you are, and you start to up the chain comes feedback that something's amiss with ventilation, it doesn't take much scratching around to realize the numbers aren't pretty. So I'm guessing you're looking at this landscape and going, look, there's a gap here. And the reason you looked at commissioning or testing, I guess, is because of the nature of your organization. You didn't look at this and go, we're going to start training installers how to install ventilation systems better, or we're going to start training designers to design ventilations. Your comfort place is as a testing organization. So naturally you went, I know what we can bring to bear here is better testing and rigor over outcomes. And I made a note, and I think it's really analogous here with air tightness testing. And that is one of the complaints in ventilation, is it's quite a disparate group. As you said, plumbers, electricians, general builders, DIYers, you name it. It doesn't have a trade per se. But then air tightness is a bit like that as well. A building arrives at a certain air tightness through multi-trade interventions. It's not something that one person has control over. So, like, this is your comfort space, isn't it? An outcome that needs to be measured, that's arrived at by a whole range of things that you don't have control over. But what can we bring to bear to that industry to make it better? And you arrived at, I know, we need people to be able to figure out how these systems are performing properly at the end of the process.
Yeah. And we have always been a testing organization. Some of our devices are calibrated to multiple decimal places, really highly calibrated pieces of kit. And we were then able to walk into the ventilation industry and have people that haven't had their kit calibrated in 10 years and go, well, this is meant to do 24. When I put my fan over it, it says 16 on the gauge, but I know that's all right. And they sign it off. And there's a couple of key moments that helped me make the decision to move ATMA into ventilation. I think they both happened within the same very short space of time. One of those was, now very rarely find myself on construction sites in the same way I used to, but I was on a construction site, and I was with a tester, one of our air testers, and he said, "Oh, I've just got this brand new vane anemometer. Should we have a quick look at the fans?" And oh, go on then. And there was zero flow from any of the fans in the building. None. Zero. I don't actually know what the problem was. It could have been filters on them. It could have been plastic. It could have been covers or something. I wasn't overly interested, but it did make me go, well, there's a surprise. And I'd walked, after I'd done my audit for the tester, naturally giving him a hard time, as we always do. We walked to the site office, and the guy that I was with still had his vane anemometer in his hand, and we walked in, and the electrician that was there who had installed the device, I know he had installed a device because he put the certificate down on the site manager's desk. It was like a film. It was like the most perfect timing. And he had written on the thing 6 liters a second, 15 liters a second, and signed a ventilation install certificate. And again, like something out of a movie or a film or a play, he turned to the tester I was with and asked him what he had in his hand. And this guy just put this down on the table. And I was just shocked that could be allowed. And it kind of opened my eyes. You know, sometimes I'll hear from some building control groups, and they'll say, you know, we always receive certificates with the numbers on. And I go, just because you receive certificates with the numbers on, my own evidence, my own eyes have seen these things show me that these aren't right. And then the second thing that happened was a wonderful report came out by the Future Homes Hub. And the Future Homes Hub had this brilliant tiny little infographic, and I've used it a million times in presentations, and it identifies the 4 key stages of ventilation. So you start with design, you then have install, you have commissioning, and you have maintenance. And it was the first time I'd seen that on paper in that format, so simple. And I thought, great, we can be number 3. Our testers can be number 3 here. They already own 50% of the kit that you need in order to be able to do this. So our testers can be number 3. Number 2 is kind of already looked after in the UK by the NIC EIC. They have an installers course. I think 1,000 people a year go on that training course. The design, well, we'll get to that. But my thoughts are, I can't do the design without employing a new member of staff. I don't really have the skill set to do the install. I'm out of my comfort zone. I do have the skill set to do the commissioning and measuring of things. That's been my entire life since I studied engineering. Measuring of things was what we do. So at that point, I said, we can be number 3. And actually, if I push hard enough and we get as many powered flow hoods into people's hands as we can, and they measure stuff, it will shock the system. So then number 2, the installer, gets a shock if something goes wrong. And number 2, theoretically, can turn to the designer and say, I've installed it exactly as you requested. So by seeing that on paper, I was able to go, we are part number 3 of 4, and I can set this thing up in weeks. And we just did. We have here the Building Performance Hub. We had a bunch of leftover wood, and me and Stan from Sega built 3 ventilation bays here in the hub, and then installed an absolute bunch of ventilation stuff. So we said, right, well, let's create the training course. Let's create a certification program, and let's get this thing going. And yeah, that was the start of us getting involved. Yeah.
And easy, huh? Look, you know, that's the end of the story. Because you said,
yes. Yes and no. We to set the thing up very easy, and right now we have a very good training program. We take 2 days to teach what's currently taught in 1 hour, the airflow commissioning and all the ventilation strategies. We take 2 days to run for a very thorough course. We spent a huge amount of money on IT. We have the certification scheme written in accordance with ISO 17024. We're ready to go. And the next stage was we went to local government, and the future home standards were being written. They've always been written, but they were being written 2 years ago. And we said, hey, we've already done this. Here is our plan. This is what we think should happen. And yeah, they were very, very receptive. We were quite pleased with that. So we made a lot of progress, and then just nothing. Stop. Hardline. There is no requirement to join a certification scheme. There is, up until the building safety regulator jumped in, there was no requirement to show that you are competent to do anything in construction. And now that competency, or the requirement to demonstrate competency, is coming in. Our training courses are sold out every time, because the people doing it and doing it properly want to make sure that they are competent and doing it correctly. So it's been a weird journey, but it was only when I spoke to you, actually, maybe 18 months ago, 2 years ago, and you said, "Oh, have you seen the way the Irish guys do it?" No. And I think you'd sent me a couple of their website and how they do it. And we had managed to write almost identically the same certification scheme with the same training requirements and extremely similar outcomes to the way they had done it. And they had got it into their regulation in 2019, or started it in 2019. And we're still 5 years down the road, have the certification scheme ready, but not able to quite get the thing over the line and get it required and written into the regulations.
The interesting thing here for me is that, like, you say, like, you sat down and you said, right, we need to write something for commissioning. So you sit down, and I think that's what a lot of people don't appreciate, is that ventilation's not that hard. There's
have
not.
You heard how I wrote the standard? Have you heard the story?
On a plane, literally on the way back from Australia. Yeah. Because like if you understand standards, and you understand enough about ventilation systems and the testing methodologies that are understood, that are available at the moment, there's not actually a lot to it. So and if you're a quality type person, and you think, right, how do I go through a process of making sure somebody's got the competency to measure this stuff? I think people could start almost completely in the blind in different jurisdictions and end up with largely the same methodology. And I think that's quite reassuring, that you said, having spoken to me, you looked at what the Irish are doing, and it was remarkably similar. Well, that's confidence building, because it says that we're probably all doing roughly the same thing. There's going to be T's to cross and I's to dot and tweaks and things like that to improve it. But fundamentally, this is a process of measuring air. How complex can it be? Now, there are some nuances, and we'll definitely come into it in different testing methodologies and like practically how this is going to be implemented. But like the process of actually writing an A to B document that says, okay, if we were to sit down over a couple of days and people were to come out the other side of this with the knowledge they needed to go out there and test ventilation, this isn't like a corgi course where you've got to figure out how to maintain a boiler or something. This is measuring ventilation.
And I think, let's not overcomplicate it. You and I both sit on a bunch of committees and a bunch of forums. And I sit and I think we constantly are trying to overcomplicate this thing. If you remember my analogy, stage 1, 2, 3, and 4, we're number 3. Let's not overcomplicate this. We don't have to do the conditional measuring approach. If we just take the unconditional measuring approach using powered flow hoods, then measuring ventilation is incredibly easy. You walk up to a vent, you lift the hood, it gives you a number, and the answer is that number bigger than this number. And you go, right, well, that's on a very top end. That's what we do. There's a level down below that, which is we need to work out what that number needs to be. We have great software that does a lot of that for you, and that's kind of a level 2 thing. But actually, I think this industry is, and potentially sometimes the government could sit here and go, we could train up a bunch of people to do ventilation, to get the measurements done. This could be the start of a career for a lot of people. We can enable them, if you've got a driving license, and you can somehow get hold of the kit, be it you hire the kit or you borrow the kit or you buy the kit, you can go out tomorrow. You could do a 2-day training course with us, receive your certification, and go out into the field and start doing these measurements and checking. It's not been as simple as that, because we know there is a substantial amount of fans and ventilation systems that are failing to meet the minimum requirements. There's a bunch of ATMA members that no longer carry out ventilation testing because the failure rate was so high that it upset the relationship between their customer and them. So they stopped doing it and only carried on doing the air tightness testing. And for me, that just is completely alarming, that they were failing these things, and it was causing problems in relationships. So on one hand, yes, we have this great, it's very easy to go and measure. And if 50 of us in the ventilation industry sat down to write a standard on how to do the measurements, we would come out with, 1 or 2 similar looking standards. Brilliant. But the real problem we have in this industry isn't doing the measurements. To some extent, it's not even being forced to do the measurements. It's ventilation, much like acoustics and noise control. When it goes wrong, it's painful. If you're talking a fan that goes through a hole in the wall, not so painful. But if you're talking the failure of a ducted system, you don't know what the problem is. You just know it. You can measure maybe at one point and you can measure at another point, but you don't know where in between those 2 points something has gone wrong. So it becomes a real big issue in having to fix those things. And that's where the problem lies. But we're never going to get over that problem unless we either A, design it right, stage 1, or we start commissioning them and failing them so that we can learn, the industry can learn. And I think the industry's over here in England and Wales, the industry is going to have a bit of a shock over the next few years, as this ventilation, which has been mandatory to measure it since 2010, we think only between 5 and 10% of buildings actually get measured for their ventilation flow rates. When the more of these that are done, we're going to identify these problems early doors, and the industry is going to be in for a bit of a shock. But that's how it was when air tightness testing came in 2006 in England and Wales, and it was a shock to the system. Suddenly the builders had to learn this whole new thing, and individual trades had to be conscious of their work. And you briefly touched on it earlier. Air tightness is this multifaceted thing like ventilation. The difference with air tightness is there was consequence to getting it wrong. And the consequence wasn't as you would expect it to be, which is the homeowner would complain and you'd come and have to put it right. The consequence was very, very simple. You could not produce your energy performance certificate without the air tightness test certificate. So you had to do your air test. You have to pass your air test. It goes into the energy model and spews out an EPC. Ventilation, I've been lobbying the government for a very long time. The way you fix ventilation is to use that exact same process. And we have an opportunity now with the new home energy modelling coming out, that the certificates for the ventilation commissioning should be collected in that energy model before it can be used to produce an EPC. Therefore, you can't have builders not having certificates from competent people that are lodged and recorded in the system in order to fix these buildings. What happened was the SAP assessors became the air tightness police almost by accident. It was never designed that way. It just naturally happened. And what was also really interesting is a substantial amount of the SAP assessors were also air tightness testers. So when they received a competitor's certificate that wasn't part of a competent person scheme, the first thing they did was kick it straight back and say, I pay my fees, I pay my dues, I have my kit calibrated, you've just submitted to me one that doesn't, I'm not accepting that. And the SAP assessors became the air tightness police. The SAP assessors, or the HEM assessors as it will likely be, are in this great opportunity where they may become the ventilation police, because they're going to receive these certificates and they're going to go, fantastic, this is great. Or they're going to look at it and say, this has been written by Joe Bloggs on an email. This hasn't come through a competent person scheme or a certification scheme. And I'm not willing to accept this and put my professional indemnity on the line to produce you an EPC. So I think we're in this, there's an opportunity that's about to come out where we could follow the air tightness model and ensure that substantially more buildings, if not 100% of every single building in this country, has the ventilation actually measured once it's been installed.
Yeah, there's an awful lot there that I want to try and unpack, Barry, and I've been furiously writing notes, trying not to forget some really important points that you've touched on. The first one, just to reverse back up a little bit, because I think we're probably going to touch on it a few times during the conversation. And for those not from this world, and we've got international audiences that may call it slightly different things as well, I think it's worth us explaining just very briefly this tier of ventilation testing or measurement that we understand as the unconditional, conditional and minimum benchmark method, because we'll say it a few times. And I think if people don't know what that means, it will be hard for them to put it into context. So originally, out of some work that was done by Bizria well over 10, maybe even nearly 15 years ago, when this concept was first pulled together, we ended up with a standard document that was created in the UK that defined ventilation in 3 tiers effectively, didn't it?
Or the measurement of ventilation, yeah.
The measurement of ventilation, yeah.
So we had the unconditional approach. The unconditional approach uses powered flow hoods, and powered flow hoods take away any back pressure that's caused by placing the hood over the fan. So there's a small motor, small fan that spins up, makes sure the pressure is even on both sides. And it's called unconditional because the reading you get is the actual airflow plus or minus margin of error. The number 2 is the unconditional approach. So the unconditional approach.
Sorry, the conditional approach.
Sorry, conditional approach. Thanks,
yeah.
Son. The conditional approach is, even I get it wrong, using rotating vane anemometers. So rotating vane anemometers, when you place them over a fan, they create a back pressure on the fan that's greater than the back pressure it would normally operate in the room, and therefore reduces the flow rate of that fan. So your indicated flow rate is not your actual flow rate. You have to do a calculation in order to get there, and you look up your numbers on 2 separate graphs. One is your equipment graph, and one is your the published flow rates from the manufacturer graph, and you do a calculation. So you can figure out your actual flow rate. Even to this day, there is a very, very, very large German manufacturer of equipment. I'm not going to name them because we'll definitely get sued between us. But they denied that this was a thing. You know, they were selling rotating vane anemometers. They probably sold 1 million around the world. And I've asked them for their back pressure corrections, and they said the fan doesn't cause back pressure, or the rotating vane anemometer doesn't cause back pressure. And I recorded this video. Maybe one day I'll release it, but I recorded a video of myself using powered flow hoods and rotating vane anemometers here at the hub, and showed them, hey, you get a different answer. I kind of wonder why that might be. And it took them a very, very long time to come back to me, and they never really truly came back to me. And they just kind of denied it was a thing. So even within the people creating the equipment, there's a denial that there's a problem. I see a lot of people saying to me on, I'll get back to the third method in a sec. There's a lot of people that say to me on LinkedIn, whenever I do my measurements, I never quite get them all to add up. And I say that's because when you restrict the flow of one duct, it just forces the air out faster in another duct. And sometimes that's because you may have a 6-inch duct, but the vane anemometer is 4 inches. So you get a restriction, like squeezing a hose pipe. So the pressure goes up, the flow goes down. The third approach we have in the UK was work done between BISRIA and I believe the NHBC, and it made its way into a really good document called BG46, which has formed the basis for airflow rate measurement in England and Wales for a little while. And what it effectively said is we've measured a bunch of fans, and if you put the rotating vane anemometer over a fan, we can roughly account for the backflow. So if your fan needs to measure at 30 litres a second, if it says, I think it's 24, if your indicated speed, airflow speed is 24 litres a second, sorry, flow, not speed, then that's actually, if by the time you would do all of the calculations, it would come out at probably 32. So there's a margin of error, but what it enabled testers to do in this country was to use much cheaper kit, rotating vane anemometers. We're talking a fifth of the price of a powered flow hood. You're able to go in, quickly measure with a reasonable margin of error, which works. And in my head, as a testing man, I go through stages of going, great, don't let perfect get in the way of good. It's a way of measuring stuff. It's okay. But then the science man in me goes, what are we doing? We're guessing. We can't be guessing. The tools are out there to take accurate measurements. We should take accurate measurements.
Yeah.
So I flip between the two.
I can well imagine. Yeah. And I have particular views on that, but to try and condense that perhaps into as concise a way as possible, the clues are in the name. An unconditional testing approach is there's no conditions. You press a button, the number you see is the number you get. And as long as your equipment is accurate and you know how to use it, it's the most unconditional way of testing that equipment. The conditional approach means you need to do some maths, and you need the information to be able to do some maths, and look at some graphs and understand what you're doing. There's some conditions associated with it. And a straw poll of, probably like you did, of people that do these testing, I found precisely 0 of the people that I spoke to understood how to do those calculations, right? So there's a whole bunch of people running around using this equipment, thinking the number that they're seeing is the number that they're getting. Now, the advantage we have with that miscalculation, shall we say, is that the number that you read is always lower than the number that you get. So at least they're inaccurate on the right side of the line, that hopefully the systems are doing more than they're getting.
But also, that also creates a different problem though, because if you have a fan that needs to achieve 15 litres a second and your device is showing, say, 12 litres a second, and you don't understand that you've created a back pressure and reduced the flow of that fan, you're now going to have to tell your building contractor that fan has failed to meet the requirements. That contractor now is going to rip that fan out, replace it. You may have 5 or 6 of these in a home, all of which you've just told they failed. They rip them out, they have to replace them all. But actually there was nothing wrong with them and they've met the minimum requirements. So it's a double-edged sword. We must be careful of that.
Yeah, and in any testing process, the accuracy of both the device and the process that you go through is really important, because you need to understand where you sit in the world. And one of the challenges that we've had in Ireland has been getting alignment between the people that are commissioning ventilation systems and the people that are coming along and validating them, because somebody that's commissioning it might be using an unpowered flow hood and getting within the ballpark, and assuming they're seeing something that they don't. And then a validator is coming along later on in the process and not able to achieve the same numbers. And you then start, whether it's a regulatory problem or not, what it does is it creates a friction in the marketplace where people don't trust each other, where you have a misunderstanding of what you're actually seeing. And also some products out there that, so people are aware, don't necessarily have an ability to increase ventilation in very small increments. So you may only have a choice of having 13 litres a second at a particular fan. And if you're reading 9 on it and thinking that it's not doing what it should do, you can't increase it by 2 or 3 litres a second often. That's it. So you might find yourself in a position where you're throwing something away or saying it's not doing the job when it is. But I think more fundamental than all of that, and I think you nailed it really, when we're in a position to get an accurate reading, why are we messing around with something that doesn't give us an accurate reading, or have the knowledge to get the accurate reading through those calculations? That why put yourself in that position? Field measurement comes with enough confounding factors as it is.
Yeah. I mean,
without relying on
Let's look at the rest of the construction industry. Would electricians take a guess? It's about 50 amps. No. Would window fitters, would we do this with anyone that takes accurate measurements in construction? Would you take the concrete slump rate and go, it's about that. We think it's about that. We'll be okay. You wouldn't do that in substantial other parts of the industry where it is life and death. And as much as people say or may counter, ventilation is a life, or it's my opinion. Ventilation is critical. It's a life critical part of a construction, because if you're in a very airtight home, and I'm the first person to stand up and say this, if you're in a very airtight home and you do not have adequate ventilation, you are very, very quickly and very likely going to have problems. And that may be mold, that may be humidity, that could be building sickness of a ton of varieties. And, it goes right back to my original point. If you're going to build an airtight home, you have to ventilate it correctly. And that doesn't just mean put some fans in. That means actually achieve the required minimum flow rates. And I argue with a lot of people all the time. They go, why would you build an airtight home and then have these fans that are removing air? And because you're making assumptions that the amount of air being removed by these fans is equal to having a leaky building, and it's not. They're two very different things. One is a controlled at source, controlling humidity coming on when you need it to and off when you need it to. And one of those is just gaps and cracks in your home that allow cold breezes through places you don't want them to be coming in. This airtightness ventilation link just needs to be very clear. They both go hand in hand. Do not make your home airtight if you are not going to ventilate it correctly. On the flip side, do not spend £10,000 on the most high-end ventilation strategy and system you can find, and don't make your house nice and airtight. You are throwing money down the drain. The two things, part F and part, I think, and as much as airtightness, I'm forever saying airtightness is not ventilation. Air leakage in your home is not ventilation. You must never, ever use airtightness tools to measure ventilation, ever. That will be written on my gravestone. But, hear me out. I think the airtightness side of, or the testing requirement in the English and Welsh regulation should be moved into Approved Document F, which is our ventilation regulation. Approved Document L is all about the thermal efficiency of the building. It sets the minimum targets for our energy modeling. Your doors must be this U value, your windows this U value, CO2. But I think that airtightness needs to come out of that section and be next to ventilation. It should be, you need to make your house airtight and you need to ventilate appropriately and have both of those measured so that they're in the same document. It would just make our life a little bit easier and create that link between the two that is super clear, that you can't have one without the other. And that goes both ways.
Yeah, but and I'd hope, listeners to this podcast know that, the importance of air quality on health. And I think the challenge that ventilation has always had is can be quite non-dramatic. I mean, when it goes wrong with damp and mold, it can be quite visually dramatic. But the challenge we've always had with air quality is we tend to kill people slowly. Stuff doesn't tend to burst into flames, or water doesn't pour through your ceiling, or you don't get a smell of gas and blow a building up, and all of those dramatic things that require very precise standards around stuff for safety. the challenge we have is we kill you in 40 or 50 years with lung cancer or early onset dementia or cardiovascular disease.
We've seen some horrendous cases in the UK, some awful cases where it's taken just 1 or 2 years. And I think the building regulations in this country and the enforcement of them is very much focused on things that if they go wrong, you'd have to call an ambulance. If you wouldn't have to call an ambulance, then we're very relaxed about them. So that's, air tightness, ventilation, to some extent, some of the water stuff. But if it doesn't go wrong very quickly, as you say, in an explosion or you would have to call an ambulance if it went wrong. Electrics is another great example. Then we're pretty relaxed, and we need to change that. We need to look at air quality and indoor air quality. Actually, approved document F has this wonderful section at the back that says, hey, you don't actually even need to measure ventilation. If you can prove all of these metrics are being met, and formaldehyde and I don't think CO2 is actually in there, but it contains a bunch of pretty nasty stuff that outgasses from natural building. If you can prove those numbers are actually below the requirements set in the standard, then the dwelling is considered appropriately ventilated. And I think actually we don't look at that section of the regs. I don't know of anyone that's ever used that section of the regs to demonstrate compliance. But, that is written in there, and we should probably look at that a lot more. I think we should be, if we could rewrite the regulations from scratch, we should be saying, we've got two things. We need to set the ventilation flow rates, make sure the system works. But every single home should have an air quality monitor on the wall. And I'm not talking, £25,000, all singing, all dancing, you've probably got one, super high end that measures unbelievably. I mean, by now, technology's moved on enough. We use the Aware air quality sensors all through our offices here, and they measure particulate matter, CO2, temperature, humidity, the basics, as I would call them. And it's enough for us to get a good gauge of where we are. And I think when I bought them, £100. I mean, why aren't we putting these things in every home for a year?
Well, you're pushing on you're pushing on an open door with me, as you can imagine, Barry. I mean, the truth is, and I've been saying it for a while, so I'm going to have to be right at some point. Otherwise, people are going to stop believing me. Effectively, I've been saying for a while that within the decade or so, we're not going to be measured on whether our building complied at the point of construction. Will be benchmarked against the ongoing performance of the air quality in the spaces that we occupy, and that's a very different world to occupy. One of the sensors I've got behind me here measures pretty much every value that's in the back of ADF in the UK. The formaldehydes, the nitrogen dioxides, the CO2, the carbon monoxide, ozone, you name it, it measures it. So that technology exists already, and it's coming down. Every 2-3 years, there's a seismic shift in power, performance, connectivity, costs of sensors. This stuff is moving rapidly. And we're already in a place now where we're seeing large scale deployments of environmental sensors into things like social housing, that brings very particular value propositions to that sector. That means it's worth them paying to put them into properties. So we're seeing hundreds of thousands of sensors going in a year into just the UK market because of that. And so we're running out of road. At some point, people are turning around and already turning around to the sector and going, objectively, this space isn't performing. Explain yourself. And it won't matter whether you said you met a particular standard at the point of construction. You're going to live and die by the ongoing reputation that building's performance gives you. But I think it brings us back to one of the notes I made a little while ago before we started breaking down those testing methods. And I want to come back to a couple of them a bit later on, because I think it's an interesting conversation. But you made a point that I think reflects the where we are piece, and that is that you have people that operate in a space of air tightness testing, that's been around now for half a decade or more even, are used to a certain level of quality and understanding and language in the sector, have gone and started doing ventilation testing and walked away going, this is ruining my bloody business relationships with people because everything I'm measuring is shit. And I can't keep telling people that this is a problem. And that's a reflection of what we see in the data and the studies that happen out there, is that somewhere, and this is a Europe-wide problem and probably broader than that, in the region of 60 to 80% of properties are not doing what they should do from a perspective of ventilation. Now, I know of no other sector where that would be tolerable. You know, that if you were seeing, and bearing in mind, these are minimum standards. This isn't some gold, lofty, platinum, well standard thing we're trying to achieve here. This is a minimum standard for typical buildings in typical scenarios, as all these standards are written. And every time we go and look at it, and I mean every time we look at it, you are more likely to find a building that's nowhere near doing what it should do than you are finding one that's close. And that
I think air tightness has exposed it. I think this is part of the problem. I think since 2002 it first was mentioned, 2006 it came in as a regulation. We're now in 2025. Air tightness exposed this problem. It was never a problem. Well, you could get away with a chunk of it. There was a bit of a problem, but our homes were so leaky that they were saying, you know, they were ventilated by accident. You know, there's a good sound clip. Ventilated by accident. And now people are, you know, kind of referring to leaky homes as ventilation. You know, air infiltration is ventilation. It's not. We did that by accident. We did that because we didn't know how to build better. We've learned over those last 25 years. And part of that, those air tightness values come down, exposed our issues with ventilation, that we've relied so heavily on our buildings being so inefficient that ventilation wasn't seen to be a problem. And we were only seeing these problems accidentally in, my mother, for example, lives in a post-war prefab concrete home, and she had issue with mold. And it was because we had this uninsulated concrete wall, and the house was super airtight. And it was one of these kind of exceptions where you get these accidental constructions where you get these homes that, you know, the bathroom was at the back of the home where there was, you know, no sunlight during the day. It's just where the orientation of the home. And it was built out of solid concrete with no insulation. So it naturally would occur. But other than that, we built these leaky homes that were accidentally ventilated, and the air tightness coming in made these homes more efficient to heat. And I will argue that point until the cows come home. It is a good thing. Airtight homes help reduce fuel poverty by making it cheaper to heat the home. But we need to figure out the ventilation side of that. You know, making sure that we use mechanical ventilation once we make our homes nice and airtight. But I interrupted you there, but I wanted to get that point there. I think it's a really good point. Where I was heading with the question, I suppose, was the way that you presented the statement around people kind of walking away from the process because it was just creating too much friction speaks to potentially a broader friction. And that is, if you don't test, you don't have to confront the problem that you've got, right? And you could see that as a potential problem. And I was wondering, as someone that's been so heavily involved with air tightness testing for so long, whether there's been any equivalence there from lessons learned from an air tightness perspective, that when we first started doing this and we started attaching the completion of buildings to air tightness tests, that we were getting horrendous results and results that we weren't comfortable with. Because I remember at the beginning of air tightness testing, we used to just test 1 in 10 or 1 in 20. And so you could soften it a little bit like that to say, well, okay, it doesn't look as bad as it is because I'm only actually testing a proportion of them. And if I find problems, then I zero in. But has there been some equivalence in that journey, do you think, that air tightness has gone on, that we can say, look, don't panic too much. We know it's a shit show out there,
but we've been here before. This is what the trajectory is likely to look like.
Yeah, I'll actually respond with a positive. So when 2006 came in, the people knew that air tightness was coming. And once the regulation is out there and it's made clear, when I first got into air tightness testing, I did a substantial number of air tightness tests for people that knew it was coming, didn't need to do it, but wanted to get a feel for where they were. And I think we have this big fear in the ventilation world that, we can't possibly change it because the building contractors will freak out and lobby and, no one's going to like it. Everything's going to fail and go wrong. But actually the point at which the regulation became regulation, the industry reacts to it and says, right, it's in, it isn't going anywhere. How do we fix it? And in those early days, in 2006 or so, we went and showed people, and the target then was 10, and we went and tested a bunch of people's houses, and they got 7s and 8s, the lower the better in the air leakage game. And it put them at ease. They go, great, actually, we're doing the right thing. We're happy with where we are. And because you've done the test, we've also learned a little bit, so we think we can get a bit better. And so when we go for our next stage of building, we're gonna fix that problem. So yes, there was plenty of homes that failed the tests, and they had to be repaired, and things were opened up and resealed, and there was a lot of learning that happened, and sometimes that was a bit painful. But we didn't set particularly high standards of air leakage, so it could be fixed. A lot of the problems were just simply you had a hole at the end of some boxing, so if we fix the boxing, it actually isn't so bad. But yeah, my instinct is to point towards the positive that happened. Once the law and the regulations are set, the industry reacts, and it would immediately go, right, go and test a bunch of my houses and let's see where we are. Because if we're already meeting the requirement, I don't need to worry about it. We just keep doing what we do. And I think that's where we need to get to. I seldom remember any cases where it was that bad that we walked away and things went wrong. More so sometimes on commercial buildings. If you take a big shed, a big kind of warehouse style building for air tightness, it's generally the same detail repeated 7,000 times. You have a piece of cladding that overlaps another piece of cladding. And if you don't have appropriate seals or it's not tight, you have that exact same detail wrapped around the building with hundreds and hundreds of pieces of cladding. So it's the same one problem 700 times. Or if you don't have the filler pieces in the very top of the cladding where it meets the roof, it's one detail 700 times around the building. So we tended to find commercial buildings could be quite disastrous, but actually there were often easy fixes. And the housing market was the same. We could fix things, or, they could, wouldn't go as far as bodge things, but they could make superficial repairs that would get them over the line, knowing that they could learn next time that actually here is what I need to do and here is what I need to repair. And ventilation needs to go through that journey. It needs to go through the journey of it's in the requirements. It's got moved into into ADF. This is what you're going to have to do. And the construction industry will go through, and a bunch of them will go, fantastic. Actually, we were always scared of this. We never really needed it tested, or we always thought it was being tested and we just had assumed. And we're actually okay. We've always met the requirements. And then there'll be a bunch where it goes wrong. And there are some ways we can fix that, as long as it's not a catastrophic problem with the ducting. Sometimes it might just need a slightly bigger unit being installed, or it might need a slightly bigger hole being drilled out. There will always be a small stage, but if it becomes properly ingrained in the system, we can't ignore it, and I think it will very quickly become normal. If imagine it dropped this year, 2025, by 2027, it would all the friction and all the pain will be done with, and everyone, the manufacturers will be working with all of the builders to make sure the systems are installed with potentially a bit of capacity to make sure if there are problems that the units can overcome those problems. And I think we just need to make the jump. We need to make the commitment.
I'll have you back in just a minute. I just want to borrow you briefly to talk to you about 21 degrees. a partner of the podcast. Formerly the Green Building Store, they were founded in 1995 by 3 exceptional building professionals, and the company grew out of their frustration with the poor availability of ecological building products. And I've known them for years as the go-to company in the UK for end-to-end design-led MVHR systems. You see, your home should do far more than just provide shelter and be energy efficient. If designed correctly, it'll be a far healthier and more comfortable environment. So whether you just want to start with a single product solution or need a comprehensive range of technologies to make your home more comfortable, 21 Degrees can help. In 21 Degrees, you won't find a more trustworthy, straight-talking, passionate about what they do, and approachable group of people. I speak a lot about the performance gap on this podcast and what we can achieve if we value ventilation highly enough. 21 Degrees embodies that sentiment for me. So if you're building a home, looking to install ventilation, or need to talk to experts in the field, I can't recommend them highly enough. Links are in the show notes at airqualitymatters.net, and you can find them at 21degrees.com. That's 21degrees.com. Now, back to the podcast. I can't tell you how many times I've had this conversation and around construction in general. And I don't know if it's the childbirth effect of human nature not wanting to remember something so traumatic that you do it over and over again. But every time we've introduced a standard that looks like it's going to turn the industry on its head, the industry's gone, yeah, okay, right, and get on with it. And they do it over and over and over again. Like it's littered. Doesn't matter whether it's PPE, scaffolding, safety, air tightness tests. You sit here for the next hour listing out the stuff that industry complained like hell about up until the point that they said, right, a year and a half's time, this is implemented, get on with it. They go, yeah, okay. Because it's a process. Like construction is just a manufacturing process. And anybody that's sat in a site meeting knows that site meetings aren't political meetings. Site meetings are meetings on, here's an obstacle, how do we get around it most efficiently?
Logistics, yeah.
It's logistics. We just get on with it. And I think ventilation will be no different. But I think you made 2 really interesting points there. One is with forewarning, you find the supply chain in general, and I include construction, but also the manufacturers, know it's coming and start paying attention. And they realize
they're already working on it. And I've spoke to a bunch of the big manufacturers, and they are already working on one of them, again, I won't name names, but one of them has already designed kits. So you'll know the major house builders tend to only build 10 to 15 house types, and they just orientate them differently on the sites, and it streamlines their entire process. They know that there is 2,712 bricks required for that. They know that there is X amount of timber required for the roof of that plot. It's like Lego kits to them at this stage. They are already designing and have implemented the airflow requirements, the kits that they buy. So they go to the manufacturer and they say, that's a kit number 7 for this house type. That contains exactly 12.5 meters of ducting that's running this particular channel. We need this particular power supply on the fuse board. That's already happening and being implemented right now because they know it's coming. And some of the house builders are way ahead. We had Tony Battle, who is the ex-MD of Kind & Co. on our podcast a while back. And I asked him these questions. I asked him the question, what were your thoughts when you first found out air tightness testing was coming into the regs? And, he was very open. Right, let's get on with it. It's there. Let's make it happen. Let's get some testing done. And, in a similar way, we spoke about Passive House. Right, someone approached you about Passive House. What are your thoughts? And his thoughts are, right, well, let's roll the sleeves up and figure this out, because we're going to have to do it at some point. We may as well learn now before it gets dropped on us. So if we can learn in advance how to fix these things, we're not going to be worried about it and panicking. So the construction industry, I think sometimes consultants and the media, we give them a hard time, but they are, logistical, operational businesses who are just, a lot of them are very much, hey, we build these things and we build them in these particular places, and it is an unbelievably streamlined process. It looks like chaos when you look at a construction site, but it is it's a ballet of trades, for want of a better term, all dancing around each other and making the thing happen. And sometimes the trades fall over, and sometimes we have issues. Of course we do. And sometimes you don't realize this bit of the ground is a problem and somebody didn't quite follow the plan for the brickwork here. But generally these things are pretty smooth running.
Yeah. The thing that frustrates me ever so slightly is the industry, the manufacturing side of stuff, and that is the can kicking and obfuscation that often goes on in the lead up. I mean, all industry is naturally conservative. I think it doesn't like change. It understands where it's profitable and doesn't want stuff to interfere with that. But with ventilation, a classic one years ago was decentralized fans not able to work against a decent back pressure. And the excuses that came out of the industry as to why this wasn't important and why this was an unfair requirement of the testing methodology, that their fans needed to achieve X or be tested in a certain way, you wouldn't have believed. It went on for half a decade. And some of the position papers and documents that came out were just risible. Yet the deadline came and passed, and all of a sudden, every single manufacturer has got products that meet that standard, as if by magic.
Yeah.
And you're like, come on, like really, you blocked that for half a decade, and now you've all got products that magically do this thing.
But you can imagine it if you were in a logistical and operational style business, and for those of you watching on camera, there is a chip and pin machine. If there's 3 blue buttons across the top of it, if I came out and said, we're thinking of changing that top right-hand one to green, you don't want to change it to green. Why? Because your system is slick and you've got a process and everybody knows what they're doing. And as soon as you make a change in a business, it causes things to change, people to change, processes to change. We've now got to order green buttons. And when do we implement those green buttons? And will that green button work? And do I have to now have that tested? It causes, slight bit of unsettlement. And that's what happens in the construction industry. So they will kick back and say, let's keep it blue. There's no reason. We could just keep it blue. But the second the law comes out and says, no, it needs to be green, they go, okay, we'll make it green. Because the good businesses have already made it green and have already done the testing and have already figured that stuff out. Because they've gone, oh, hang on a minute, this one's serious, this one's coming. So let's get 2 years ahead of our competitors so that on the day I can service the customers and be ready. The bad businesses are the ones that fight and get caught short at the very last hurdle because they were genuinely convinced they could overturn it. And I think we don't give the construction industry enough credit for the sheer amount of good businesses that are already today. There's businesses out there today using a lot of the airtight paints, the passive purples, as you will, or the membranes that are coming out. And they're already trying it on a few of their homes because they're looking 5-10 years into the future and saying, we're going to have to do this. Let's give it a go. Let's see what happens. Very low risk. Let's try it on one of our properties now so that we can just see, actually, is it now just a slight bump in the process, or are we going to have to do something drastic and engage design teams? And I've always been fascinated to look at the difference between the two types of companies that exist out there.
Yeah. And I think ultimately, and this is where I put so much credence in measurement, because ventilation is so eminently measurable. Certainly mechanical ventilation is. We can have a conversation about the potential of natural ventilation, but it's something that we can define a requirement to, and we can check that we got what we paid for. I think the beauty of that process, and we've seen it with air tightness testing, is that it forces the industry to fall in line. It evaporates the marketing wonkery. That I can't tell you the amount of time and resources that are pulled into trying to differentiate between one product's marketing nonsense versus another one, and what this table being presented in that way, and that and trying to, for even a layperson to even get close to navigating that space is almost impossible. all of that ends in a moment that you have to stand over the end result. It doesn't matter what your brochure said or your technical salesperson said under pressure and started pushing the boundaries a bit of the capability of a particular product. All of that stuff goes out the window the moment there's an end goal of, okay, have I got what was intended? And that changes everything. And nothing moves the supply chain faster than that, because it causes chaos for a short period of time where people are running around going, oh shit, that fan's never going to be able to do that. What do we do? So-and-so specified it and we didn't catch it. And, that particular project becomes a nightmare, but you can guarantee it doesn't happen on the next one. Everybody's got their shit together because nobody wants the embarrassment of those. Those phone calls are uncomfortable for anybody when you suddenly realize that fundamentally something isn't going to work because it was missold, misrepresented, not put in right, whatever the scenario was. There's a lot of egg on faces quickly, and the construction industry doesn't tolerate that because it's so process driven. You find the very next project that's corrected, but you have to have that definition at some point of, did I get what I paid for?
That's why the cycle is so important, and that's why the good builders are out there right now installing stuff they don't need to. They don't legally need to or have to, because they're trying to avoid those. They're learning those lessons from the past. So there's companies out there now fitting MVHR is a perfect example. They could get away with a continuous extract system and reduce some of the cost, but they're looking at their trades, they're looking at their subcontractors, they're looking at the logistics of how this goes in, and says we're going to do a site where we have this, and we're going to monitor that, what worked and what didn't. And I don't know how many contractors you've had on, but there are, you definitely should find some of those, because the ones that are doing that right are just fascinating to speak to, because they really are pushing the stuff early and trying to figure it out before the industry jumps. It's brilliant.
Yeah, it's a risk.
They just don't say it. They just don't talk about it enough.
No,
because if they talk about it, then it might drop sooner than they need to.
And there's these risk conversations that go on in these organisations. I know they do. And we saw some fascinating effects of that here in Ireland. Probably, I don't know how long ago it would be now, but maybe nearly a decade ago, where we saw some very significant changes in regulations in Ireland. And what effectively it meant was that after a period of recession where there wasn't a lot of building had gone on, some changes had happened in regulations that meant people were having to build fundamentally different buildings than they were building at scale 5-6 years previously. And at the same time, there was a culpability and accountability mechanism within the standards that had significantly changed here, which meant the risk factor went up enormously for those involved in construction. And what we saw almost instantly here was a very specific focus on making sure that what was going into buildings worked for the first time. Yeah. And because they had to actually stand over, they were legally now accountable for absolute compliance with the standards, whereas before it was all kind of opinions of compliance and a bit woolly. It became much more matter of fact. So we saw this effect in the ventilation sector where good construction companies were immediately navigating to decent manufacturers and decent designers, because they needed that assurance. They needed that backstop to say, I can stand over what's going in here, because the risk has now significantly increased. And then what we saw over the next 5 or 10 years up until now has been a soft rebound, where as they've got comfortable with these new technologies and these new processes, then the cost optimization starts coming in and people start going, well, can I get away with doing slightly less? Or is there a slightly cheaper version that, markets change and margins drop and things like that? And you see them regressing, but they've come from a point where they've leaped forward significantly enough that the rebound effect has still meant that even though they're now chasing margins harder than perhaps they were at the beginning, the quality is improved significantly. Now, it's not. Don't get me wrong. I'm not.
And they still have to meet those requirements. They still have to meet the minimum requirements.
Yeah, and I'm not painting a perfect picture here by any means. Like there's still a lot of problems. Don't get me wrong, but I think it shows an effect in the industry that if you put even something that's quite significant, that the effect can be that navigating towards quality and assurance quite quickly, and then a softening over time with cost optimization. But now you've set a new baseline, and that's, I think Peter Rickaby puts this very well about standard setting. It's not about achieving the perfect. It's about this constant incremental improvement all the time. We need to see that in ventilation. And we have it, particularly in Ireland, we've seen it. We saw a move with this development of independent validation of ventilation systems. That was a good new line in the sand. We now need to keep moving that line. We now need to start buffering and improving in those standards to keep that moving, because what happens is it stagnates and people start to
we're now starting to see that. I don't know if you've seen the graph that we have. So as part of the air tightness lodgement system, we get the air testers to record the ventilation strategy for every building they conduct an air test on. I think we take somewhere like 200 pieces of data. We probably only really need 20. One of those is the ventilation strategy, and we're able to look at that then and dissect it month by month, year by year, and see 2025 for the first time ever, more than 50% of the ventilation strategies are continuous running systems. And system 3, as we used to call it, we now have to call it continuous mechanical extract ventilation, went from 20% of the market to 40% of the market overnight. It happened so fast, and part of that was just the 2022 Part L regulation was updated. It meant the air tightness target got less, and because the air tightness target got less, the ventilation strategy had to change in accordance with the target. So we've seen some really positive change in 2025 for the market, and we're seeing now substantial amounts of ducted mechanical ventilation systems. So there has been some positive change in the UK, and we're really pleased about that. But with that also comes risk. The risk has increased because we're not measuring them properly, and we need to be very aware of if we're not measuring these things properly, we could cause more problems, because now the homes are more airtight, and the ventilation strategy is more ducting, more bends, more pressure, more everything on that ventilation strategy. So it's more important than ever to get these things measured.
Yeah, and I think for people not from an air quality background, what's really important to understand is that the actual outcomes that we're looking for, which is air quality out. I mean, that's why we don't ventilate for the sake of ventilation. We ventilate to maintain adequate air quality. There are enough things outside of your control when it comes to air quality that adding another one of poor ventilation is a confounding factor you just don't need in that equation. Even if you get everything right with ventilation, it's still no guarantee that you're going to get a good outcome from an air quality perspective. So we have to find a way of getting there with ventilation, because it's going to be hard enough in 5 or 10 years time where people are saying, I'm still not getting good outcomes, if we can't stand over the ventilation choices that we put in, and given ourselves the capacity and the robustness of those designs and installations, that we've got some flexibility to turn them up and turn them down and alter them to get the outcomes that we want. We need to be in a place my vision for 5 or 10 years time is that systems are going in 99% of the time doing what we designed them to do, with the robustness and capacity to move them up and down that line, that bandwidth, as necessary to get the outcomes that we desire in properties. But in order to do that, we have to get ourselves in a position where we can stand over designs, that somebody has made a good decision and choice about what's right for a building, and that we've checked that we got what we designed. And if we can get there, then it puts us in a position where we can start reacting to the outcomes that we're going to start measuring. from an air quality perspective.
That's interesting.
Yeah.
I think my view for 5 to 10 years' time is similar but different. I think it's inevitable that ducted ventilation strategies are going to be the norm in the UK. And System 3, just continuous extract, will be the majority of those. MVHR, obviously, it's the gold standard. But I think there's a kind of extra level between those two things. I think in 10 years' time, we're going to have these air quality sensors built in, and commissioning will change. Commissioning will have a minimum airflow rate, but these things will commission themselves, because as long as it works, the commissioning will change because we'll just need to prove that it can meet the minimum, figure out the maximum, and then the systems are going to be able to up and down the ventilation themselves. They're going to go, oh, CO2 is a little bit high in this room. Let's bump up for an hour and just do that a little bit more. Let's add a few liters a second, and then it will just work on the very basics of electronics, which is in 5 minutes' time, has the CO2 gone up or has it gone down? Is it gone up? Well, let's go up another 2 liters a second. And these things will ramp up and ramp down as required. It will figure out you don't need occupancy sensors because you can do most of this stuff based on CO2. So you can say the CO2 level down at 400 and something parts per million. Yes. Right. Well, let's turn the ventilation down because chances are my occupants have gone out and I don't want to waste energy. So let's turn this thing down. They might be on holiday. But also within that, the sensors can have formaldehyde sensors and PM 2.5 sensors and all the sensors we like built into the centralized unit. So the commissioning will change and these things will come up and down. And therefore, we're not just ventilating properties. We are managing air quality of these properties. The two things are same but different.
Yeah.
Quality and just because you ventilate doesn't mean you manage air quality. And I think this is the next link that we have to build. But by building on your point, getting the fundamentals right of ducted ventilation being run to the correct rooms, achieving the correct minimum flow rates, and still having capacity to ramp up and down, the next natural step will be we don't have to replace the ducting. We can just replace the unit. 10 years' time, let's pop a new unit on that has all of the sensors, and we don't need to worry too much about commissioning because this thing will just ramp up and down each duct or each room as required. And I think when we get to that stage, that is absolute gold standard. And then you chuck in MVHR and filters and HEPA and preheating and post-heating and all these incredible things that the MVHR can do, and fireplace mode if you have an indoor stove to ensure that your particular matter is being forced away from you as occupants while still maintaining the heat that comes into your home. We know what gold standard looks like, but there's this level in between the System 3 and System 4, continuous mechanical extract ventilation and mechanical ventilation with heat recovery, that just allows these sensors that I spoke about earlier to do their thing and ramp up and down the system. If I could buy one of those and have it installed in my house, and it was easy, absolutely I would. It's what I would want as a consumer. We don't talk enough about what consumers want and what they don't know they want. Consumers want a new build home because they think it's clean and tidy. Consumers don't always realize new build homes for the first year contain some pretty extreme chemicals that are outgassing from all of the woods and the glues, and that new car smell everyone says is amazing is the glues that you're smelling in the carpet. So people want this because they think it's clean and fresh, and I think we need to be careful of that. I had a great conversation with Alan from Airflow a while back and said to him, I see your business is much like Rolls-Royce, where you don't sell engines, you sell miles. And I said to them, you could be in a position where you're selling air quality, not ventilation systems, because they're all connected to the internet now. And if you could allow the connection to the servers, GDPR and all of the legal laws and stuff about sharing data allowed for, you could monitor these systems, because we just changed the filters in the MVHR system in this office. And one of the guys here asked me, how often should you change your filters? And I sat thinking for a few minutes, thinking, I actually don't know, because there's no indication of when I should change them. Every now and then I pop open the thing and I go, "Cool, they need changed." But some houses may need every 3 months. Some houses might be fine for every year. Some could be every 5 years if it's a weekend property. Some people that cook very heavily may need it every month. But the ventilation world just needs to be aware of this air quality and be aware. Coming back to my original point, these things could be monitored. And you could go, oh, your filters are now restricting your airflow by 10%, which means they're clogged up full of fat or dust or both. And now's the time to change them. It should be telling us when they're changed, not, oh, it's been 6 months, change your filters, because it should vary by usage.
Yeah, and what you're describing a couple of really interesting points there. One of them is this industry of demand-controlled ventilation. To give you some sense of it, in France, 95% of residential ventilation systems have been demand-controlled ventilation for more than a decade. That world exists in a lot of places. Predominantly moisture as the major control mechanism. Increasingly things like CO2, as you describe, and VOCs and things like that are coming into the picture. But it's eminently achievable in a building that is such a large asset in our lives. The cost of having that automation is not an unreal leveraging costs. In no more of a way than we expect thermostats are in rooms and automatic control of certain functions within a building, in the same way in a car, that we expect to be able to press 21 degrees and sit in a car that's at 21 degrees. That these things aren't beyond the realm and are happening. The other interesting thing you talk about is the data, the edge data, that's already often being collected in these devices that isn't being utilized yet. So the filter one is a classic example. Most modern cars now, the service of the oil isn't based on the kilometers or a time. It's based on the viscosity of the oil running around in the engine. And it will tell you, based on how you drive, when you're due to change the oil. So this kind of data, like within a heat recovery system, for example, knows when the filter needs changing, because it's probably measuring pressures either side of it. Sometimes we just haven't used that and utilized it yet. So I think all of these things are coming rapidly, and it really again paints this picture for me that very quickly in the short term, we are going to be sitting in environments that are effectively automated and telling us how they're performing. And in that world, we've got to get our shit together when it comes to the quality of the stuff that we're putting in. And it starts with, if you can't get the basics right, if something on a bit of paper tells you that fan's supposed to be able to do X and you can't demonstrate it's doing X at the point that you finish doing what you're doing, then something's seriously amiss. And I think that's the big journey that ventilation has got to go on, that, we're learning it pretty rapidly here in Ireland. I think we'll learn it in the UK if it comes through. And it also sorts out the detail. So we'll find very quickly whether the conditional testing method is an appropriate way to be doing this, because you'll find, like we're finding in Ireland, we can't get validators and commissioning engineers to get the same number, and it causes friction, and that friction has to be resolved because construction won't allow it not to be resolved. Absolutely. This stuff works itself through the mill pretty quickly. But a big thing I wanted to talk to you, because we'll run out of time as we always do, Barry, when we're chatting, is I did want to talk about the data side of this from an audit perspective, because one of the most powerful things I've seen within construction is the power of data, numbers and information. If it's recorded in the right way centrally, what that can tell you about what's happening from an output perspective, from a quality perspective. And you've seen that, haven't you, in great detail when it comes to air tightness testing. And I think you're looking to replicate that in a lot of ways in the data you're trying to collect from the commissioning, that all this stuff meshes together and is an enormously powerful tool.
We've actually already done it. we just don't have the database filled out. In air tightness testing, we now have 1.6 million lodgements. Each of those has anywhere between 50 and 700 pieces of unique information about that plot. So I think there is some stat that my developer told me we have 1 billion data points in our lodgement system, which is unbelievable. So we know a huge amount about new build construction. We know so much more. And part of that was because we decided we would take more data. Every time an air test is conducted, we wouldn't just take the bare minimum. We would take a lot of data. And we did that working through with the manufacturers, harvesting the software, doing everything we could. We built our own software. So we carried that ethos across to the ventilation side. And I think what's really cool about the ventilation process we have is that we went through and we tried to find as many of the fans that we could. So we just take System 1 standard extract fans that come on and off, 15-minute timers. We listed basically every one of those that we could ever find. We've tried to harvest the information for those on our lodgement system. But what it allows us to do is to monitor the rates of these fans, the pass and fail rates. So I've mentioned airflow already, so I'm going to pick on airflow. If they have a fan called the QT100T, I'm able to see the as-built performance of that fan thousands of times to see what it's achieving. And I can filter by the unconditional approach, so I know that there's little issues, and I can see. Theoretically, I haven't done it, but theoretically, I can plot that data on a graph, and I would be able to tell airflow before airflow maybe realized that they have a QC issue because the fans were degrading, or a step, there was a degrade in performance. Or I could pick out the batch number from the serial numbers of the fans where they had an increase in performance, maybe because they changed something internally to improve the performance. And we can do that with MVHR systems because we take the serial numbers, we take the type, we take the manufacturer. We record the flow rates in each of those rooms. We look at the address. We look at the sizes of the buildings, the volumes of the rooms. We're able to extract that information. And then we can combine it with our other databases. So the air tightness database, we know if this has been the ventilation and air tightness are now combined. You can then top that with the sound insulation and acoustic data. And then if we really choose to, we could work with companies like BTS, Build Test Solutions, who are looking at the energy monitoring data. So you can then start to build this big picture of actual as-built data for the homes with the information you've got, and start looking at trends and say, what we've noticed is that where the homes are more than, or lower than 1 on the air tightness test, and this particular fan is installed, we've noticed that this particular fan doesn't generally comply, and potentially because it then can't meet the back pressure requirements. Well, we can spot those trends, and we can feed back to the manufacturers that these are good. Or, if we really wanted to, we could create a league table for the manufacturers, maybe create some competition. Here is the highest performing System 1 4-inch fan on the market. This is the one that on average achieves the highest airflow rates as tested, as installed. And so data is everything. We can do with data what we choose to. So we can release that data to places like Public Health England, universities, institutions, obviously anonymized. We wouldn't put addresses and things. We can release that data to researchers who want to dig into that and look for trends. And they may find the most, I'm not a data scientist, but people will be able to dig into those millions of lodgements and see what was going on. And the more data we collect and add into that database, the more we can build a picture of how buildings are performing over periods of time. You could then potentially chuck in things like data from sensors, air quality sensors that are in the home, and start to say, when this happens and this happens, then this happens. Potentially even go as far as creating alarms or signals to say, we've spotted a problem before it's a problem. So data, I have a saying, data is the new gold. Data is the foundation of ATMA. And I often tell people ATMA isn't a construction company. we're just about a certification company. We're actually an IT company. We rely so heavily on our IT system. Our lodgement system makes our world go round. It contains our members' information. It contains the data. It contains everything we possibly need. So we are very much an IT business, because we even monitor our audits on the system. We upload, or we pull data by clicking on a particular test. It sends them a request for data. They upload it back to the lodgement system if they're missing any information. We conduct our audits online, and then we can track the audits and the success and failure rate of audits all through our own lodgement system. So we have a lodgement system that I wouldn't sell if someone offered me 5 million quid, because it's the fundamental heart of our business, of what we do. 6 million, I'd be tempted, but we're not.
Yeah, if there's any big pockets out there, yeah. Well, I can't remember which car manufacturer it was. Toyota, one of the Taiwanese, or one of those Korean, one of those car manufacturers actually changed its business category to data and energy, because effectively what they recognize is that they're basically big computers with batteries on wheels is what they actually make. So their ability to move power around a city in the form of mobile batteries, and the computers and communications that they have. Sorry, it was comms and batteries, a comms and batteries company. That they effectively are a massive network of communication and battery devices, is what they really are, is what they're really making.
Yeah.
And that's the value. And the value of what you're doing, like you say, is the data. And that data, if you understand deeply its context, which is what you do, like you say, that data can be turned to all sorts of valuable and hopefully not nefarious activities. Like you say, a league table, a bit like the miles per gallon, the extra urban, the real world performance of ventilation systems in the marketplace. A league table like that is exactly what I'm talking about when we talk about data, about your brand will live and die by its real world performance. So we've seen that in cars, haven't we? That cars will be bought and sold and retain value based on the real world data. And ventilate. We had this, I can't remember who we had the conversation with. It was a few months back. But we were talking about construction. Oh, it was Tim Sharp from up in Scotland. And he was talking about the construction sector in general. And it's one of the few sectors, the manufacturing processes, that has so few feedback loops from a performance and quality perspective. But that's what I think people have to recognize, how the construction sector is changing now. That is changing, and that shifts the horizon rapidly when you start to understand that performance in real time coming back to you. That changes the narrative, basically.
It does. We move away from ventilation, but it started with ventilation. What's to say energy performance certificates aren't going to be based on live data? So your energy performance certificate at the moment is a theoretical model. It could be based on live data. So suddenly you have metrics that get fed in. And I've always said that these metrics should be open. So you should be able to, if you've got good performance, you should be able to add that in. So air tightness testing will be added into the reduced data set for existing homes, because an assumption is made that home is semi-leaky, where a lot of them will be airtight, especially now air testing has been happening for 20 years. A lot of them have a negative assumption against them. So that being opened up is a good thing. But we're going to start being able to feed in data for potentially from our sensors that we have around our homes to say, this is actually high performing. You'll be able to look at electricity usage, and in particular, if you can limit that to a particular source. So if you have an electric radiator or a heat pump, for example, you'll be able to say, this heat pump uses, 1.2 kilowatts on average across a particular year or something. We have a year's worth of data. We can now feed that into the EPC and say, we thought it would use 2 kilowatts. It's now using 1.2. So that EPC goes up. What we have to figure out is how we link that to the occupancy, so what their choices are. If they're choosing to have the building hot or cold, we need to be able to isolate and figure out the algorithm to balance the requirement.
I think that will come with. I think that will come from a couple of fronts. One, open databases, a bit like we've seen with cars, where you have manufacturers presented data and you have real world performance, and people, and that will influence behaviours. People will say, "Well, hang on a minute, I'm not getting the same performance out of my house as the house next door that's the same. Is that something about how I'm driving this house?" You'll get that side of it. But you'll also get the as a service models more increasingly. Definitely, the podcast that's coming on before this, Barry, is about air quality as a service. And that was a fascinating chat. And he sees residential being quite a way off, but they're already there in some commercial buildings of being able to offer air quality as a service. And one of the interesting things about that sector is that every part of the supply chain has to be in line and working, because profitability is tied to outcomes in its entirety, which means from your warehouse through to the deployment and operational function of that service, everything has to work. And that changes everything as well, because now you are literally, the model is based on the core outcome. And that's a fascinating conversation as well. I think. Yeah,
I look forward
really
to that.
Interesting. Yeah, really interesting. So in the short term, for you and ATMA and the BCTA, I always get that wrong. I always say BTTA. BCTA. There'll be show notes, by the way, folks, where those acronyms will be explained, and there'll be links, because I can't even say I actually know what that means.
Ventilation's bad for an acronym, isn't it? Wow.
Oh my God. Yeah. You currently have a course up and running.
Yep.
We have changes in regulations due on ventilation at some point. It would appear that we're moving towards unconditional testing as the primary way of measuring ventilation systems. The direction of travel looks positive. What do you think has to happen next, specifically in the UK, to really shift this on the next gear? So from this position you're in at the moment, where you're busy, but we need to scale, like what has to happen? What jigsaw pieces need to start to be put into place?
It's super simple. It's regulation. The house builders, we touched on it a lot through this. The house builders will do what they need to do when they need to do it. And that's it. That's the bottom line. There's no, some will go earlier. Most will do it when they need to do it. They will operate to what they need to do, because house building is these are private companies. They need to make a profit. If ventilation is seen to be more expensive or a change in their slick operational system, they won't do it. Why would you? You said with my green button analogy, the only thing that will change it is if our building regulation comes out and specifically says, here is what we're doing. If there's any ambiguity in those regulations, nothing will change. If you give people an option, there's a classic example at the moment in Australia. It says in their regulations you should make sure your home is airtight, or you can go down a route which is deemed to satisfy, and you fill out a form and it says, I've built it airtight. Builders 100% of the time choose to write a document that says, I built it airtight. So it needs to just be simple. You need to have it measured. It needs to be by a competent person, and define competent person. Is it somebody that is a registered member of SIBSI? Is it somebody that has sat a specific training course? Is there a national occupational standard they must follow? So we define competency, and then we have ownership. So that certificate needs to live somewhere. Somebody needs to receive that certificate and tick a box to say they've received it. Because without those three things, the industry falls over. So that there's nothing that's going to change until then. If they come out and say, here's what a competent person is, but they don't do anything else, we'll wait for the next cycle. Because nothing, you just wouldn't do it. if somebody gave you an option for your car and said, hey, you should change your tires when they get down to 4 millimeters, but the legal limit is 1.6. When do you change your tires? 1.82 millimeters when you get right to the edge. You wouldn't do 4. Some people might. The more cautious in the world. There's always a specialist part of the industry. There's some fantastic construction companies out there building passive house stuff constantly, chucking out some incredible buildings right now. Great, but they're the substantial minority. So, as it pains me to say, there is no lobbying. There is no anything that will change anything right now except legislation.
Yeah,
it makes me sad, but it is what it is.
Yeah, and I think there's a natural resistance from some of the industry because they know products are going into the marketplace that aren't performing the way they should, and they see that as a threat. There's no doubt about that. And even good manufacturers that on one side of their mouth are producing very good products, at the same side are still selling bucket loads of dog shit bathroom fans with no quality control over the installation and process. And that's just where we are. And until you're held accountable for the installed performance of a product, that just won't change, unfortunately, because the country is full of trade counters with bathroom fans on shelves that we know aren't performing when they're going in, because there's no process behind that at all. And unfortunately, manufacturers are making a killing selling those things because there's no accountability to them. They make them at bucket prices and they go out but at the same time are selling products that achieve really great outcomes with some great technology in it. And it's this kind of Jekyll and Hyde for me in the sector. And I see it all the time. And it frustrates me. One of the things that's just a thing that annoys me. But one of the things I wanted to touch on before we finished here was around existing buildings, because particularly we're in the UK and more broadly in Europe, a vast majority of the buildings that we're going to be in 50, 60 years time exist today already. And most countries in the European area in general in the UK are undergoing major renovation retrofit of the stock. And in the UK, for example, we've got standards like PAS that are starting to intimate at the least that you should measure performance of ventilation systems. Do you see that as an interesting area for development from a quality perspective?
Certainly is, yes. There is a lot of very good and very bad things happening with retrofit. Without trying to get myself sued, I'll focus on the good to start with. We have a great document, PAS 2030-2035, sets out the right way of going about things. It makes it pretty clear when you should do things and when you don't need to do things. And it requires you to install appropriate ventilation and have it measured, have your air tightness measured so that you can know what appropriate ventilation is, and you can it's included as an integral part of retrofit. It's fantastic. However, the negatives are that there are a bunch of things that allow you to bypass a ton of those rules. There are certification schemes that are set up that are avoiding you needing to do things like undercut doors when you really should be doing those things. When you change the fundamental internal characteristics of the air inside a home by adjusting the dew point, by increasing the humidity, by improving the thermals of a building, you need to address the ventilation properly. That requires allowing air movement around a home. And by being able to bypass some of those things, having certification schemes literally set up to avoid the need to install the basic minimum requirement of ventilation, we are setting ourselves up for a complete fail and to have to redo all of the retrofit work again, because we're now making our homes nice and warm and not fixing the ventilation problem.
And you make a fantastic point. Yeah, you make a fantastic point there. And it leans on something that I said a little while ago, and that is decent outcomes are hard enough to achieve even when you get everything right with ventilation. Yeah. So where you start to create environments where we're providing people with workarounds for not doing the basics, if history has taught us anything in construction, when we set up environments like that, it never ends up anywhere good, ever. Like I probably don't need to recount to listeners the cacophony of poor outcomes that have happened in the construction sector because we've allowed industry to develop sneaky workarounds for stuff. And this is a nail on the head moment there.
And
for sure,
it's something I've been pretty proactively lobbying against. And those of you that know me will know exactly what I'm talking about. I don't want to go down and get myself sued, but having any process that bypasses what's written in the building regulations is a dangerous game. As you mentioned, there has been fires that have happened. You look at Australia and New Zealand have had the pink bat syndrome. You've had all over the world, there's examples of bypassing the requirements to save money or time. And even if you do it for the right intentions, there's a reason a lot of those regulations are written. So when you start bypassing them, you are in for trouble. The particular one I'm talking about, I've sat in the CEO's office and told him he's going to have to sit in front of a jury one day and explain deaths of people in a polite way without getting your podcast an R rating. And I was ushered out the door, and I stand by what I say, because it is what we can't be doing is exactly what I've said, increasing humidity because we're reducing dew point, we're increasing thermal efficiency, and we are not dealing with the ventilation. We are creating these lovely hot boxes, which are great for if you want to heat your home and make it cheaper, but are going to cause problems in people's homes. And as you say, we can't allow this to happen. We've got to learn. We've got to not do this stuff.
And I come at it from perhaps a slightly different angle in that I just know how difficult it is to stand over outcomes anyway in the built environment. And so when you start introducing things that make that more complex, you're just lining yourself up for a hiding. Interestingly, though, I've been part of a group developing a retrofit course for ventilation here in Ireland. And there are some interesting conundrums that come up, particularly with existing buildings. And that the first one is that in most kind of common law environments, you can't insist an older building that may have met a previous standard meets a new standard unless it's changed significantly enough that you can justify that it now needs to meet a new standard. So in some environments where we're doing major renovation and deep retrofits and whatever terms you use, you're changing a building significantly enough that you can make an argument that it now needs to meet certain new regulations because it's fundamentally altered, right? And I think most people get that. But the challenge with renovation more broadly and maintenance and the existing stock broadly is that there is a massive grey area where there isn't in new build and major renovation. And it's those nuanced environments that we need to be training people to understand risk management. And as you said, as an organization, never mind outcomes and protecting consumers, as an individual or as an organization, we have to recognize that there's a risk in retrofit that you have to manage. And you've got existing expectations of people that are living in buildings as built and in service, as the kind of the Neil Murray white paper describes it. So you've got existing concepts of how that space is supposed to perform. You are going to change it. So people are going to experience a change in performance and have an opinion about that. We have existing risks that you may either mitigate or make worse as part of what you're doing. That's just retrofit. Retrofit is hard. You know, whether we're talking about radon risk, whether we're talking about moisture risk, whether we're talking about all of these things, we need to take countenance of where a building is starting from and where potentially we're taking it to and how we manage that risk. And as you say, where we start finding ways of going, here, look, it's a leaky building. We can get away with not doing something because it's going to get in the way of installing windows or insulation or whatever the thing is. Like we've just been here before. We know where this goes. Like anybody that's been around construction long enough, it's littered with a history of poor outcomes for people. And this is real people and real people's lives we're messing with. This isn't just here's a bit of mold might appear in a bedroom. We'll get away. That'll be 5 years down the road. We'll get away with it. Ventilation and poor air quality outcomes don't even have to have a visible outcome to kill somebody. You know, there are homes that we may that create poor outcomes for that the homeowners may never see a difference in. But it will give them lung cancer in 40 years' time, or it will cause cardiovascular disease or early onset Alzheimer's. And over the next 30 or 40 years, believe me, we're going to have an awful lot more evidence of this stuff. And people are going to be sat in uncomfortable courtrooms trying to explain why they were trying to dodge and navigate their way around basic principles of ventilation because it got in the way of installing insulation. And that for me is because, and I'm not saying there's anything wrong necessarily with any of these methodologies, that the trouble is from a risk perspective, it's hard enough anyway, the built environment, to get this stuff right without finding things to obfuscate from.
Yeah, and going back right to your original point there, it's the difference between legislation and morals and ethics. So perfect example that I give people is if I was to be selling a 1950s Porsche, I don't have one and I wouldn't sell it if I had one, but if I had a 1950s Porsche, it doesn't need its MOT certificate. That's the annual vehicle inspection, because it predates the annual vehicle inspection requirements, the law. But if I sold it to you, took the massive wheels that used to come on things, you know, these things might be the best part of 20 inches wide, and I put on a set from a Morris Minor, then legally I've not broken any rules, right? I've given you a car that can drive on its wheels. Ethically and morally, I've committed two cardinal sins. One is that I've now given you something that is potentially dangerous, isn't going to be able to accelerate and brake as designed. And two, I've committed a cardinal sin of putting Morris Minor wheels on a Porsche. But, the difference between what is right legislation and what is right morally and ethically, those things need to be balanced. Just because one meets the requirements of the law of the day doesn't mean it's the morally or ethically the right thing to do. And worse is if there is evidence to suggest it. And this is where Grenfell Fire got so wrapped up, is that they knew the stuff was flammable that went onto the outside of that building, but they still put it on anyway. And right now in construction, we know ventilation is underperforming, but we're still putting it in anyway. And I know one isn't as extreme as the other, but as you point out, in 10, 20, 30, 40 years' time, we're going to feel the effects of this and be dragged through the courtrooms. So
we're already feeling it, Barry. You know, air quality is the single largest environmental risk we face as a human species. Like it is already, we now know that our exposure to air pollutants is multi-systemic. There isn't an organ in the body that isn't impacted by air quality. Like I say, whether it's cognitive early onset dementia, Alzheimer's through to cardiovascular disease, liver, kidney cancers, autoimmune issues, low birth weights, endocrine disruption, you name it. You know, we are being impacted by these poor outcomes. The evidence is suggesting that at least in the UK market, something around 60 to 80% of buildings are non-compliant, aren't even making it to the minimum line benchmark. So we know we've got a fundamental problem. And to quote the lady from the Grenfell inquiry, if you don't feel the weight of responsibility here in this sector for getting it right, then you're in the wrong industry and you need to get out. And that's kind of my view at this stage with ventilation. And that applies across manufacturers, designers, installers. The evidence is overwhelming. We are not getting this right enough from retrofit to new build. And if you don't feel the weight of responsibility here for the people that you are killing, then you are in the wrong industry and you need to go and find another job. And it's that simple. And this is coming to an end, because at some point those ventilation systems are going to be measured, and you are going to have to stand over the stuff that you sold or designed or installed. And even worse than that, in a short period of time, we are going to be measuring this stuff in 5 and 6 years post installation, and your brand will be decimated by poor performance. Whether it's data on your database that's saying, I'm sorry, but that brand has never performed. Every time we go out and test it, we see that, don't we, in lists, these commercial lists all over the world. You get the brands that are sunk because of publicly available information about their actual performance in the real world.
Yep.
And they become a joke.
Yeah, that was great. I was holding my breath there as you were talking, because I thought this sound clip needs to be just a link in the building regulations that you click, and it says exactly what you've just said there. I do hope you clip that and put that on LinkedIn, because I will copy that and I will put that on the front page of ATMA, because that's exactly how I feel. If you are not in the industry for the right reasons, if you're in it for a quick buck, if you're taking shortcuts, frankly, do you have a bleep? I wasn't.
You're allowed to swear on this podcast. Yeah.
Frankly, fuck off. Get gone. We don't want you. The industry doesn't want you. The consumers don't want you. If you're only in it for a quick buck for yourself, those times are gone. It's 2025. The building safety regulators kicked in. It is time to stand up and be accountable. Do your best work. And hey, if that means you have to put your prices up, put your prices up. That means it's going to take you a little bit longer to do the job properly. Great. Pay the fees. Because if everybody does that, everybody's price goes up, and we don't have the race to the bottom. We don't have the cheapest people doing the worst job. If you need to, don't accept mediocrity. Don't accept the lowest level. If you need to put your price up, let's do it. Let's be better as an industry.
Yeah. No, I couldn't agree more. But I think that's a perfect note to end the podcast.
Oh, great finish. That last few seconds was fantastic. Yeah.
Listen, Barry, mate, I appreciate your time. It's been great talking to you as ever. I really appreciate you taking time out of your day to talk to you about ventilation and testing, mate. Barry, thanks a million. Thanks for listening. Before you go, can I ask a favour? If you enjoyed the podcast and know somebody else who might be interested, do spread the word and let's keep building this community. This podcast was brought to you in partnership with Erico, ACO, Ultra Protect, Imbiot and 21 Degrees, all great companies who share the vision of the podcast and aren't here by accident. Your support of them helps them support this show. Do check them out in the links and in the show notes and at airqualitymatters.net. And don't forget to check out the YouTube channel by the same name, with plenty more content due to come on that channel. Thanks very much. See you next week.